Okay. Hello, everybody. Welcome to my talk on alternative ways to think about serverless. My name is Chris. I work for a company called Amido. We're doing all sorts of hiring at the minute, so if you fancy working on cloud-based software, then come and talk to us. We're downstairs. So, first of all, I want you to meet Bob. Bob is from many, many years ago, and he has his own field. And he uses this field to grow vegetables. He plows his field. He really loves his field. His field is very important to him. It provides for his family. He's been down the local drinking establishment, and he's heard of this new thing called fieldless. Now, fieldless is this idea that you don't necessarily look after your own field, but you delegate that responsibility of food to a third party. So now he's investigating going and buying his vegetables from a vegetable vendor, from a market. And now he has more time for himself. He can spend that time with his family, he can learn more skills, he can use those skills to earn more money. So at the beginning he was kind of skeptical. You know, can I really trust someone else to grow my food for me? Can I guarantee the security of my own food? But actually, overall, it turns out he's better off. So he delegated all those concerns of growing food to someone else, to someone who's better capable, somebody who's better at doing it. And I think it's clear to me that over history, we've moved to move this undifferentiating heavy lifting away from us. So, you know, whether it's building cars, providing food, or providing medical help, we're not really doing these things ourselves. We're letting other people do them for us. And I think the cloud shouldn't really be any different. In fact, I think years from now, we'll look back at this period where we weren't programming in a serverless way against a serverless model, and think that's kind of weird, and it will seem as weird as programming against a mainframe does now. So let's talk about a few different definitions. So this one's by a chap called Paul Johnston. He's an ex-senior dev advocate for Amazon in the serverless or area, in the Lambda area. He said a serverless solution is one that costs you nothing to run if no one's using it. And broadly speaking, I agree with this. It's a great one-liner. It's a great place to start, but it doesn't necessarily encapsulate the operational side, which is, I think, pretty important. Simon Wardley of Wardley Maps fame, he says that serverless is an event-driven, utility-based, stateless code execution environment. And again, I agree with this. He actually goes on to say in the same Twitter thread that he asked a question: if you want to toast some toast, would you go and buy a $40 toaster, or would you spend thousands of dollars buying the raw materials and building a toaster for yourself? You probably wouldn't. You just buy a toaster. I think the same applies to executing code. Why not get someone else to execute it for you? Wikipedia, the source of truth, right? We go to Wikipedia for what we believe to be an unbiased opinion. And they say that serverless computing is a cloud computing execution model, which again I agree with, but it doesn't really tackle the storage side, which I think is equally as important. So, my definition. I think the term serverless is actually a little bit misleading. For me, it's about utility compute. If you think about the utility services you have at home, you've got water, there's gas, electricity, and the thing that makes those utility is the fact that A, you don't really care how it gets to your house, it just appears there. Secondly, it's on demand, so you can use those utility services when you want to. And lastly, you pay for just about what you need, near enough. And I think the same applies to serverless. You don't need to worry about how it happens, it just happens. It's available on demand, and you pay for just what you need. So, is serverless right for your project? And I thought it'd be interesting to do some analysis on the cost of serverless in different scenarios and to see exactly what you get. So, I did a bunch of tests in AWS, just because I had to pick one of them. So for compute, on the compute side, I defined what I'm calling a unit of compute. So basically, calculating a bunch of prime numbers, large prime numbers, and factorials, and seeing how many of that unit of compute I could execute in a given period of time on whatever instance or serverless configuration or Lambda configuration that I'd chosen. And for the storage side, I created a large number of documents with random data in them and stored those in either S3 or in RDS and run a bunch of tests on transactions per second, so how many reads I can do in a second over time, and the kind of response times that I got from those. So the things that I learned from that. So on the compute side, the first thing was, this is quite interesting, I expected that the larger the instance you bought, the more compute you get done per dollar. Actually, it turns out it's the other way around. So the most effective way, the cheapest way to get stuff done in instance-based compute is actually using the smallest available instances. So that was quite interesting. And the second thing here was that Lambdas pretty much cost the same in terms of dollars per unit of compute. So it doesn't matter whether you have a memory configuration. So in Lambda, you set the memory, the amount of memory that function will have. If you double the memory, you double the amount of compute that's available to it. And if you double the compute, you get a precisely double the memory, you get precisely double the compute again. It turns out that if the task you're doing is actually highly CPU intensive, there's no reason not to pick the highest possible configuration, because you're going to get the same amount of work done for the same price. It will just get done a lot quicker. So the last thing on the compute side was to do with the sharp stabilization of costs that occur. So in this graph here, what I'm trying to show here is that as you increase the amount of work you do per hour in these tests, so that's going that way here, and we've got two lines. So the orange line represents the ratio of instance-based to serverless costs. So as the line goes down this way, that's basically saying that instance-based compute is cheaper. And this line here is 1, so this is the point of parity in the middle. The blue line is the number of instances that are required to do that amount of work along the bottom here. So the interesting thing is that point of inflection is exactly at one instance. So basically, if you can use anything up to 1 instance worth of compute, you might as well do it in a serverless way. It's going to be a lot cheaper. Anything more than that, it's probably going to be cheaper to do it on instance-based compute. But interestingly, this line is completely flat. So once you get beyond that point, it's going to be roughly half. This is a log scale. Roughly half the cost to do it in an instance-based system. But there's much more to costs than just the direct compute costs. So we're going to come back to that in a moment. On the storage side, a few things we learned. So firstly, it turns out you actually get quite a lot of performance out of a very small RDS instance. So this was a DBT2 micro. So the smallest possible one, you get at least 4,000 TPS, which I thought was quite high. And actually, that makes the serverless storage offerings look really expensive from a dollar per request basis. And secondly, response times for S3, so the serverless compute that the serverless storage that AWS offer, aren't that great. And I didn't include Dynamo in this test. I think it would have been quite different. But I mean, Dynamo serves a different purpose. S3 is more for distributed clients. But yeah, quite a lot slower. I mean, it may not matter in your scenario. So we're sort of talking 30 milliseconds instead of under 1 millisecond. But it's still, for me, surprisingly slow. And in terms of, so the last thing on the storage side is that this stabilization occurs a little bit later. So here, we've got transactions per second going on this way. On the orange line shows instance-based to serverless costs ratio. So again, along here, this is the point of parity. And you can see that it's cheaper to run instance-based for quite a bit longer, serverless it becomes cheaper to go instance-based quite a lot sooner in this journey across to the right. That I guess given the first test where I realized it was quite cheap to do storage in RDS, this I guess is a little bit less surprising. So this is all really interesting, but actually it's all a bit wrong. So if there's one thing I want you to take away from this talk, that is that if anybody presents to you some kind of presentation where they look at the direct costs in this way, a cost-based justification for not using serverless, I want you to think really hard about what you do next. So they might be right, and in certain high-load scenarios, they may be, but in most cases they won't be, and this is why. So it's really easy to get drawn into a discussion about the cloud provider costs over there on the left-hand side. But actually, there are a bunch of other costs as well. Operational, dev overhead, outages. So operational costs like monitoring your gear, testing an application with new OS versions, scaling, this kind of stuff. Outages, you're probably not going to be as good as a provider at making your stuff reliable, so you're probably going to get an outage every now and again. And the dev overhead we'll come back to in a little bit. So in terms of relative size, I mean, it's really subjective. There's no real way to measure this on a general basis, but the chances are that these other costs are much higher than your provider costs. And if you go to a serverless way of thinking about this, so your cloud provider costs may be a bit higher, but in terms of outages, again, the provider is probably better at keeping the stuff up and running than you are. Operational costs are going to be lower. There's less stuff to worry about. And the dev overhead as well is less. And that's what we're going to talk about next. So how does the dev overhead get reduced when it comes to serverless? I think there are three things here. The first one is high cost transparency. So I'm sure we've all been in a scenario where you've got some code and you think it doesn't perform very well, or someone's made that kind of assertion, and you say, okay, well, we should make that better. It's not good that it doesn't perform. But if the end user experience is okay, then actually in a serverless world, you can look at the direct costs associated with that function and say, okay, well, that function is costing us X number of pounds per day for being as slow as it is. Can we justify the development time to invest in that? It becomes a business decision. You bring that business decision into the normal prioritization process, which doesn't normally or may not occur when you don't have that transparency. So avoiding work is one of the best ways that we can cut costs. So work that isn't necessarily required is a way to reduce costs. Code encapsulation. So this is more of a fast benefit, a function as a service, but fast and serverless tend to be associated. If you've got some bad code, some code that doesn't necessarily work in the way that you want it to, or it maybe it needs to be refactored, but no one wants to touch it. If you put it in a function, the function actually works functionally, then maybe that doesn't matter. It may be some work that you just don't need to do. So again, you can avoid doing some dev effort. And the last one is a naturally distributed nature. So in a world where most of the applications that we develop are distributed in nature, they're event-driven, there's actually, these programming models fit really well with a serverless execution model. And when you bring these two things together, you find yourself making less mistakes. So poka-yoke is a Japanese term for mistake avoidance, so avoiding unintended mistakes and errors. And I think if you bring these two things together, if you bring two models together, a programming model and an execution model that should be together, the chances are you're going to make less long-term and costly mistakes. So next time you think about starting a new project, just think about Bob and Bob's experience. Maybe you'll want to go fieldless too. If you've got any questions or comments, please tweet me. I'd love to hear them. Thank you.